Hello guys, welcome to Pre.Code, and today we are solving this problem, that is GCD of prefixes. In this problem, firstly we should know what is this GCD. Let me give you some brief about this GCD. GCD means greatest common factor. What does this mean? This means if we have two numbers n1 and n2, then then GCD stands for number which is maximum and it is able to divide n1 and n2 properly. Okay, so now how to find this? For solving the GCD problems, we should know some methods. But for finding GCD, I remember only one formula. That is Euclidean's sigmoid, and something is less optimized. That is Euclid's subtraction. I think subtraction like that. And then we have one more Euclidean, that is enhanced part modulus. So we can go with this flow. Okay. In this flow, for example, we have to know the GCD of uh, n1 comma n2. Then it is equals to GCD of n1 modulus n2, or we can say n2, and here we have to take n2, that is minimum, where n1 is greater by n2, and we have to call these function recursively, so that one of the number will be 0 and other number will be the resultant GCD. So I can tell you this with one example, like GCD of 12 comma 18. So first step, GCD of max minus min, that is 18 minus 12, that is 6, right? 6 comma minimum number between 12 and 18 is 12. So go next, GCD of max minus min, that means 12 minus 6, that is again 6. And what is the minimum number? Minimum number will be 6. So go next, GCD of max minus min, that is 0. We find this 0 and minimum number will be 6. So the GCD of this problem, that is 12 comma 18, is 6. Okay. um I can also write one dummy code for you guys. For example, we have this int n1, that is 12, and int n2, that is 18. Okay, now we have to iterate up to any one number of will be 0. Either n1 will be 0 or either n2 will be 0. Then we can getting out from the loop. So firstly we have to find the minimum. So min min value is equals to minimum of n1 comma n2. Okay, then we have to find the max value for this, and that is max n1 comma n2. Then we have to find this reminder, that is rem is equals to uh, max value minus min value. For optimization, we can also rewrite as max value modulus min value. You can write the theory for these methods, right? Then you can know how it works. Now uh, we have to swap the number n2, swap the number this position, this n2 with the minimum number, with the minimum guy, with the minimum guy, and this n1 is replaced with this remainder. Okay, so after this loop, we have to check if n1 is equals to 0, then cout will be the n2. Otherwise, otherwise n2 is equals to 0. Then n1 will be the GCD. And this is the simple solution for the GCD problems. I'm so sorry, guys. Okay, that is 6. Right now, we can go go next for this problem. Now, Suzuki and Itachi are playing a game. Suzuki first creates a array A containing n positive integers a1 to an, and he then creates a new array B of length n such that B of I is equals to GCD this for each 1 to n. Now Suzuki gives an array B to Itachi and asks him to find an array A. Okay, okay, okay. As per I read this question, I get one point that we have one array which contains elements, that is a1 comma a2 comma a3 and up to an. Right now, we also have one more array, that is b, and which contains b1 comma b2 comma b3 up to b of n. But twist is that this b1 is calculated is like a1. Okay, now how b2 will be calculated? GCD of a1 comma a2. Right. Now what about b3? b3 will be calculated b3 will be calculated like GCD of a1 comma a2 comma a3. Okay, now what is this GCD means? This will result b1. This b1 means the number present for uh, the candidate of GCD are fully divisible by this b1. So if this b2 can able to divide a1 and a2, this can also divide the GCD of a1, because internally if b2 divides a1, then b2 is can also able to divide b1. This is the key observation. So for finding b of I is equals to, we need to find GCD of b I minus 1 comma a I for that particular position, and this is what we can write here. Okay, what next? Now, input, the first line of input contains a single integer t denoting the number of test cases. This t means the number of test cases. Okay, the first line of each test case contain n. This will represent the size of the array. The second line contains n space separated integer, that is b1, b2, b3, 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 b4. Okay, we are given this B array and we have to find this A array. Okay, one possible answer for 4 and 26. We can go through with the example. Let's suppose we have this A. No, no, no. We have this B, right? And what is the B? 4. 4 and 2. right? 4 and 2. Now, what this B1 means for, right? This B1 means GCD of 4, comma 0 if we don't have any number. Now, what is this B2 means? B2 means 2 and which means GCD of uh, GCD of A1, comma A2, right? So at that, according to this observation, we can also replace this A1 with this B1. So, 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 GCD of A1 is replaced by B1, comma A2. That is again equal to GCD of 4, comma A2, which should be equal to this 2. Now, according to the definition of GCD, this 2 is the highest common factor of 4 and A2, right? So, the easiest way to find this A2, we have to uh, we have to replace this 2 with this. For example, if we can find nahi, if A2 will be the any number which can divide both 4 and that number, right? Modulus 2 is equals to 0, right? So A2 will be the eligible to get the GCD for 2. Now, this 2 is equals to GCD of 4, comma this 2 will again repeated here. So the A array will be 4, comma 2. That's it. We have to return this array, right? We can also, if this is 26, right? This number will be anything. This number will be anything which can satisfy this. So 26 can also divide by 2 and 4 is also divided by 2. So we can put here any number which is divisible by 2, so that if we can able to find the GCD between that number and 4, we will get this 2 as an answer. Okay. So in code we should have to rewrite like that. I can remove this all now. Firstly, we have this t, cn of t, while iterating all over these test cases, then taking input for this n, which represents the size of this array. Then we are taking the int, vector of int, which represents b of size n, then iterate over iterate over the b, so we can taking input for bi. Now uh bool, no, yes, we can also able to take a bool like 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 uh, it's applicable is equals to false. Okay, now we can iterate over this loop. I is equals to 0, comma I is less than n, I plus if b of I minus 1 modulus b of I. So this I will be negative. So we can iterate over 1 and n is, is applicable. We can also put not equal to 0. Then this is applicable to false. And now if this is applicable, then we have to iterate auto I B out I. Okay, else C out minus 1. C out and then अम्मा दिए मोमबत्ती and that's it. We can finding the answer. Now I can tell you one more thing. I can tell you one more thing. This is the key observation. And second thing is that I can also tell you one more thing for this question. For example, we have this array 12, 18, 30 and 42. Now this will be the A array. Okay. Now we can find B for it. And you can see uh, what's and how it's going on. Now for B1 is equals to GCD of 12. That is 12, right? Now B2 GCD of 12 comma 18. That is 6. Okay, 6. Now for B3 is equals to GCD of 12 comma 18 comma 3. This is again 6. B4 is equals to GCD of 12, 18, 30, 42 is again 6. So, can you see this? If we can, if I can replace this whole thing with this B2, there is no problem. Because if this number can able to divide these both numbers, then he can also able to find also able to divide the GCD of both the numbers, right? So now we can also replace this with the 6, and this 6 comma 30 will again replaced with 6. So this will be the B array, right? So it's always equal to the element or in the decreasing manner. But if we have B like B B is equals to 1 comma 3. What does this mean? This mean B1 is equals to GCD of 1 comma 0. That's okay. That's true condition. No problem. Now for B2 we have to find GCD of 1 comma 1 comma 1 comma 3. That is equals to, no. We have that second number and GCD becomes 3. Is this possible that 3 can divide 1? No, no, never. Because at this step, GCD is this one. In next step, we get GCD 3. That means this is a wrong statement. This is not possible. So we return -1 in that case. If this modulus is not equals to 0. If this modulus is not equals to 0, 0. And that's it. If you have facing any type of the problem, you can connect me anytime on a Instagram, that is Preet underscore DHAMU. And if you can also connect me on the YouTube channel, right? No problem. Bye bye.